Sorry, y'all, that video got cut. Okay, so like I was saying, anything raised to the zero power is always going to be a value of 1. And if you have a base with a negative exponent, you do the reciprocal of it, and then it's going to change into a positive. So your rule here is that you cannot leave a negative exponent in your answer. So let's do some examples here. I'm so sorry that this. So examples, number 1, let's say I have 7 raised to the negative second power. I can't have a negative exponent, so I'm going to create a fraction. I don't have a fraction. So that base of 7 is going to go in the denominator, and the negative 2 is now going to turn into a positive 2. Well, I need a placeholder here, so I'm going to put the number 1. So that's how I would fix that. I could also say that 7 squared is 49. So either or are correct. So that's how you would fix that. Let's do another example. Let's say I have a raised to the negative third power and b raised to the fourth power. So I know that I can't have a negative exponent. And let's think about this problem. Well, first of all, I know I can't have a negative exponent, so I don't have a fraction. I'm going to create a fraction bar. The only base with the negative exponent is the one that you need to fix. So since the a has a negative exponent, I'm going to put it in the opposite spot. So right now it's understood to be in the numerator, so I'm going to change it to the denominator. Since I moved it, that negative goes away. So now instead of a negative 3, it's a raised to the positive 3. And there's absolutely nothing wrong with the b to the fourth. So I'm going to keep it in the numerator. Okay. Here we go. Let's do another one. So let's say that I have 7xy raised to the negative fourth. Well, we have to understand that in this problem, I technically have 3 bases. I know I can't have a negative exponent, so I'm going to go ahead and draw my fraction bar. The negative 4 is only an exponent for the y. So that means that the 7 is understood to have an exponent of 1. The x is also understood to have an exponent of 1. And the y has an exponent of negative 4. I know my rule states that I can't have negative exponents. So that y is going to go in the opposite place. So I'm going to put it in the denominator. And instead of a negative 4, it's going to turn into a positive 4. And the 7 and the x are fine. So I'm going to keep them in the numerator. Check your answer. No negative exponents. You're good to go. If you still have a negative, then that means you're still not completely done with the problem. So let's do a few more before my time runs out. So let's say that I have, let's do something a little bit trickier. 4a raised to the negative 6 all over 6b negative 2. Okay, so I'm going to draw my fraction bar. The exponent of the 4 is a 1. The exponent for the 6 is also a 1. So the 4 is fine where it's at. The 6 is fine where it's at. Let me look at this a. I can't have a negative exponent, so I'm going to put the a in the opposite position. So I'm going to put it in the denominator, and instead of a negative 6, it's going to turn into a positive 6. The b is in the denominator, so the opposite of it being in the denominator is going to be putting it in the numerator and changing that negative 2 to a positive 2. Right? Let's do another one. Let's say I have a base of a raised to the 0, b raised to the negative 2. My rule states that anything raised to the 0 is going to give me a value of 1. That b cannot have a negative exponent, so I'm going to make my fraction bar, and instead of a negative 2, it's going to become a positive. One last one. Let's say that I have x to the 2, y to the 3, all raised to the 0 power. Remember, anything, absolutely anything raised to the power of 0 is 1. I will explain how to do your homework in the Canvas instructions. You can write your homework on a sheet of notebook paper.